Today we are going to discuss about the covalent bonding. Previously we had discussion on ionic bondings. Covalent bond is basically formed by the mutual sharing of electrons. Instead of this, ionic bonds are formed by the complete transfer of electrons. In covalent bonding, there is no complete transfer of electrons. Atoms share together, atom combine together by sharing of electrons. The elements of group 13 to group 17 form covalent bond. All are non-metals. Covalent bonds are formed between the non-metals. When two atoms come closer to each other, their electrons repel each other, and the electrons of one atom and the nucleus of another atom, as we know, nucleus having positive charge, electrons having negative charge, they attract each other. So when the attractive forces dominate the repulsive forces, when the atoms are too closer to each other, then the covalent bond is formed by the release of energy. If the one pair of electron is shared between two bonded atoms, then it is called a single covalent bond. When two electron pairs are shared between the bonded atom, this is called as double covalent bond. When there are three electron pairs are shared between the two bonded atoms, then it is called as triple covalent bond. Here you can see the example of water molecule. One electron pair is shared between this hydrogen and this oxygen, and one electron pair is shared between this hydrogen and this oxygen. So here you can see two single covalent bonds are present between water molecule, because at a time one electron pair is shared between two bonded atoms. In a double covalent bond, two electron pairs are shared at a time between two bonded atoms. This carbon is sharing its two electrons with the two electrons of this oxygen atom, and carbon is also sharing its two electrons with the two electrons of this oxygen atom. As we know, carbon having 4 electrons in its outermost shell. So by sharing with the oxygen atoms, carbon attains 6 electrons and oxygen of both atoms attains 8 electrons in their outermost shell, not 6. Count these 2 electrons of carbon, and these 2 electrons of carbons are shared with the 2 electrons of this oxygen and 2 electrons of this oxygen. So now count electrons for carbon: 1, 2, 3, 4, 5, 6, 7, 8. These 8 electrons are shared with the carbon. So octet of carbon is completed. Now count for this oxygen atom: 1, 2, 3, 4, 5, 6, 7, 8. Now this oxygen also having 8 electrons. Count for this oxygen atom: 1, 2, 3, 4, 5, 6, 7, 8. Now 8 electrons for this carbon oxygen atom. By sharing, all 3 atoms are completing their octet. Triple bond is formed by the sharing of 3 bond pairs of electron between two bonded atoms. Nitrogen having 5 electrons in their outermost shell. So 3 electrons from each nitrogen shared with the 3 electrons of another nitrogen atom, because those atoms need 3 electrons. By taking 3 electrons, by sharing 3 electrons, this nitrogen atom will attain 8 electrons in their outermost shell, and attaining 3 electrons, sharing 3 electrons by this nitrogen atom, attain 8 electrons in their outermost shell. Due to sharing, count 1, 2, 3, 4, 5, 6, 7, 8 for this nitrogen atom. Count by this nitrogen atom: 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons in this nitrogen atom. So by sharing, both the bonded atom complete their octet rule, complete their outermost shell. Here you can see single covalent bonds example of hydrogen molecule. This is H2. Each hydrogen atom having 1 electron in its outermost shell. So both share their 1 electron with each other and make a molecule and make a hydrogen gas. They share their electron in this way. 1 electron by this hydrogen atom and 1 electron by this hydrogen atom. They share their electron. These pair of electron move for some time around this nucleus of hydrogen atom, and this electron pair move around this hydrogen atom's nucleus for some time. In this way, they share the bond pair and make a single covalent bond. Single covalent bond is represented by a single line between two bonded atoms, like this single line, single straight line. Here you can see one electron in this hydrogen atom and one electron in this hydrogen. These two electrons are shared between these two hydrogen atoms. Here you can see the example of hydrogen chloride, HCl. The bond between hydrogen chloride is a single covalent bond. Hydrogen having one electron in its outermost shell and chlorine having 7 electrons in its outermost shell. Chlorine needs 1 electron and hydrogen needs 1 electron to complete its duplet, and chlorine needs 1 electron to complete its octet. So that's why these both atoms share their 1 electron. So one bond pair is shared between these two atoms. This is single covalent bond. Here you can see another example of single covalent bond. In this single covalent bond, this is a bond between chlorine and a chlorine atom. This is chlorine gas, chlorine molecule. As we know, chlorine having 7 electrons in its outermost shell, so both these chlorine atom will share their 1 electron in this way and make a sharing. Now you can see the octet of both atoms are completed by sharing their electrons. Here you can see another example of single covalent bond. This single covalent bond is methane molecule. There are 4 single covalent bonds between methane molecule. This carbon having 4 electrons in its outermost shell and oxygens having 1 electron in their outermost shell. So carbon needs 4 electrons to complete its octet. That's why this carbon is attached with 4 hydrogen atoms to complete its octet. Each hydrogen atoms need 2 electrons to complete its duplet. So that's why each hydrogen atom is just sharing its 1 electron with the 1 electron of carbon. Here you can see one bond pair is shared, one bond pair is shared, one bond pair is shared, and one bond pair is shared. Duplet of all 4 hydrogens are completed and octet of this one carbon atom is completed. You can count 1, 2, 3, 4, 5, 6, 7 and 8. So now carbon having 8 electrons, its octet is completed. This is a single covalent bond. In this molecule of methane, there are 4 single covalent bonds. Here you can see the 4 single covalent bonds in methane molecule. Now you having the example of double covalent bond. In a double covalent bond, 2 bond pairs are shared between 2 bonded atoms. This oxygen atom will share its 2 electrons and this oxygen atom will also share its 2 electrons. So by sharing 2 electrons from these 2 oxygen atoms, they will complete their 8 electrons in their outermost shell. Count for this atom 1, 2, 3, 4, 5, 6, 7, 8 and count for this atom 1, 2, 3, 4, 5, 6, 7, 8. So octet of both atoms are completed by sharing their 2 electrons. Double covalent bond is represented by double lines. Here you can see oxygen atoms. Each oxygen atom having 6 electrons in their outermost shell. Each electron is shared with each oxygen atom. In this way, they are making 2 bonds at a time. That's why it is called as double covalent bond, because they are making double bonds by sharing 2 bond pairs. Here we having another example of double covalent bond of ethene. Carbon having 4 electrons in its outermost shell and oxygen having 1 electrons in its outermost shell. So each hydrogen atom share its 1 electron. Carbon share its 1 electron with the each hydrogen atom and 2 electrons with the other carbon atom at a time. Here you can see there are 1, 2, 3, 4, 4 single bonds and 1 double covalent bond. So this ethine having 1 double covalent bond. Double covalent bond is represented as double line and single covalent bonds are represented as single line. These 4 are single covalent bonds, but this one is the double covalent bond because at a time two bonded atoms are sharing 2 electron pairs. This carbon is sharing its 2 electron and this carbon is also sharing its 2 electron. That's why it is called as double covalent bond. This hydrogen is sharing 1 electron and this carbon is sharing 1 electron with this hydrogen. That's why it is called as single covalent bond. Here you can see the structure with the electrons. Two electrons are shared by these 2 carbon atoms and one electron is shared by these hydrogen atoms. When they share the electrons, the atoms come closer to each other and they looks little bit like this. They are sharing their electrons. You can see these 2 carbons have shared 2 bond pairs and carbon and hydrogen are sharing one electron, one pair of electrons. Next, we having an example of triple covalent bond. Triple covalent bond is formed by the sharing of 3 bond pairs between 2 bonded atoms, and triple covalent bond is represented as 3 lines, triple lines. Nitrogen having 5 electrons in their outermost shell need 3 electrons. Both the hydrogens need 3 electrons. So that's why they share 3 electrons with the other nitrogen atom. So 3 electrons are shared at a time between 2 bonded atoms. That's why they are making triple covalent bond. Here you can see the proper electronic sharing. 1 electron, 2 electron, 3 electron, 1, 2 and 3 electrons. These 3 electrons between 2 nitrogen atoms are shared. They come closer to each other and make a triple bond. This triple bond is represented as triple lines between these 2 bonded atoms. By sharing 3 electrons, both atoms complete their octet. You can count for this nitrogen 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons now this nitrogen having. Count for this nitrogen atom 1, 2, 3, 4, 5, 6, 7, 8. Now 8 electrons for this nitrogen atom. In this way both the atoms complete their octet and becomes stable. Here is the last example for triple covalent bond of ethine. Carbon having 4 electrons in its outermost shell. So it needs 4 electrons to complete its octet. So this carbon atom makes single covalent bond with the hydrogen and 3 bonds at a time with the another carbon atom. You can see 3 electrons of this carbon atoms are shared with the 3 electrons of this carbon atom. So these 2 carbon atoms are making triple bond by sharing 3 bond pairs at a time with each other. So when 2 bonded atoms are sharing 3 bond pairs, these 2 bonded atoms are sharing 3 bond pairs of electrons. They are making triple covalent bond. Triple covalent bond is represented as triple line. We have studied 2 examples. The triple bond between nitrogen atoms and the triple bond between ethyne. Here you can see the proper electronic structure between these two, between the ethyne's atom. 3 bond pairs are shared between these two carbon atoms, and 1 bond pair is shared between hydrogen and carbon, and this hydrogen and this carbon. So in this way, 2 single covalent bonds and 1 triple covalent bond is formed in the structure of ethyne.